Good evening, everyone. This is in continuation to the last video which I have uploaded on various topics which I am going to upload onto my YouTube channel. This is more relevant and particular towards the practical statistics and its importance, uh, particularly for engineers and management graduates, as well as the professionals. It will be very helpful. And this is from the different courses which I have been conducting. One of the most popular courses as a program for the industry participants across Pan India as well as for MNCs, which I have delivered. Today's session will be focused on introduction to practical statistics and its importance. We'll be largely be covering about why should we know and what is the simplicity. And will deal with very less amount of uh, derivations and other part, but more about practical applications. So with that, let me jump into the presentation, what I have scheduled for today, and let us get on to that to know if you have questions, you can always come back to me in my email ID, or you can ping me in my LinkedIn apps, or you can post me. We can always connect back. And today's discussion is more towards importance. This course is uh, delivered across for industry participants the last 10 years, 10 to 12 years, as the RISE consulting services has been made. And it has been, one of the most successful courses or most demanded courses across the industry. And it is delivered irrespective of the sectors, automotive, aerospace, medical devices, or healthcare industries. And I draw the material from RISE Consultancy Services, where we have delivered the industry programs. I honestly believe that this will be useful for engineering graduates, postgraduates, researchers who are all out of college, and also the practicing professionals. It is my sincere attempt towards the sharing of my knowledge, what I have gained across various associations I'm attached with, apart from my past employers, mentors, mentees, and across the customers of RISE and other professional associations with whom I'm attached with. And, generally when it is coming to statistics, people get averse, particularly professionals, more professionals in the sense engineering graduates and, medicos as well as management graduates to an extent get averse in terms of what is this is going to do and how it is going to be helpful to me, and what are all the things which I can get benefited out of it. Why should I know the statistics? Generally, in engineering industry, I'm more attaching these presentations towards the practical orientation of how it will benefit, having a knowledge on statistics, how it will help out in product and process excellences. That is my crux of the whole discussion and this entire program, for which this will be beneficial later point of time towards some of the most important topics for engineering, like design of experiments. When the discussions, this is one of the pictures. What you are seeing is one of the, incidences which has happened in one of the products on the road. It got into flames. Generally, whenever an incident, a product defect or a product quality issues comes up, it's my experience from my 40 years plus, irrespective of the industries, we jump to the conclusion based on my experience. This could be the reasons, and go and look at that particular opportunity as an root cause to fix without going for an investigations. Like it could be in this case, probably, like people debate that it could be from short circuits, from a PCB, blah, 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 blah. Or, it could be something else. This is based on my perceptions. That's what people normally talk about. Or jump to the conclusion. What we invariably miss is the data, the statistical analysis. we are not doing an extensive investigation into this data based on which to arrive at the conclusion. I have seen, irrespective of my sectors which I have worked for, be it medical industries, or it is automotive, or it is locomotive, or it is aerospace combinations, or in research, we immediately jump to the conclusion, okay, let us go and fix this. And some of the time, the moment the issue without doing a data analysis is being made, you know, for a time being, it appears that all the focus is being paid onto that. It will appear that the issue is fixed, but later point of time, I have always seen that it is getting repeated. One of the interesting story is one of the, dead man waking up in the postmortem room before the postmortem. This is the history which has happened in 10 years back, close to 10 years back. And recently also I have read this type of incidences. Here, the interesting point is, towards seeing the doctor, the head of the hospital, hospital talking, maggot eat human tissues. Usually they are dead bodies have maggots. This is what he has made, and the guy who has got up. So the conclusions were made on perception, saying when the man was brought to the hospital, he is dead and declared and sent to the mortuary. And like after that, like when he has woken up, fortunate for him and fortunate for all of us, a life was saved. But the thought was based on this. This is based on perceptions, not based on data, or not based on investigations, extensive data analysis. So it recollects my thought in terms of what the quality guru Dr. Deming used to say, in God we trust, all others must bring data. So this is the need and importance of all engineering applications, and engineering professionals should know, and how to use it is what we will see from the data, what are we going to make benefit out of it. So I borrow the quote from Dr. Deming saying, like all the in God we trust, all others must bring data. This is one of my most popular things whenever I work on the data analysis. I always pick it up. See, there is the data can tell you variations. Variations given in a dimension, be it height or be it weight or be it a process, be it a manufacturing measurements, manufacturing particulars like length, diameter, pins, or like output of a car in terms of fuelage. The customer more particularly wanting what is whether it is consistent across the time period where he is using. So variation gives a dimension about over a period of time what is happening, or for a various phenomenon characteristics what it is going to happen. So to know about the variation, we need to know about the data, what it is presenting. So say for example, like when we say the body weight, of a human being, maybe like let me take my example of my weight is around 67 kilos. If I say that 67 kgs is what is my whole body weight, but if you look at the distributions, the variations are into various spots that I have presented here in this picture, which is the one of the IEC standards, which gives the distribution in terms of how much is then and from knee to foot, how much is from hip to knee, and whole body of the centroid. So this is how the distribution is based on the length and measurements of human. How much is the weight of the head is, and like this is how the variation combines various components comes in. This is applicable to all the parts. It is quite interesting if you look at the stomach of our part, and this is particularly for of specific importance when pinhole surgeries happens. When the opening happens, they will finally, after closing all the surgical procedures, they will staple it. When they are stapling it, one location has got 2.2 mm thickness, another location has got 3.5 mm thickness, another location has got 3.8 mm thickness. If you look at the variation in thickness, if I have taken the stapler, if I have manufacturer of a stapler, if I have developed a product, which can 2.2 millimeter, and that may not be able to probably catch the tissues and staple the tissues by 3.8 millimeters. So what is the we need to understand that the variation is present in all the components. So that's the reason why I picked it up. So variation is a natural phenomenon. We are going to see at later point of time. There are two variations. One is special cause variation. Another one is a common cause variation as we move forward in some of the slides. Particularly, I have taken some of the nature's pictures in terms of the variation. Within a single tree, you will see the various sizes, various colors of the fruits, and various colors of the fruits which is hanging up. This is just product, but engineered products, we make the product when we are making the engineered products. There is always a variation every time when we make measurements. For example, from my recent history of when I met with my physician, my BP measurements were measured. Doctor's advice was to me, when it is exceeding more than 135 and 90, you should start taking the tablet. So when I climbed up the stairs and when I went and taken rest and I have made a measurement, they were showing it across 150/85. I was very sure that it is not 150/85. And second time measurement, it showed about 140. It was taken on the left hand. And the next time, I was not convinced about the measurements. Then we have taken it on the right side, right hand. When we have taken that, I did find that it was about 130 and 90 is what we have found. So the variation, it is not only from the product, it's also from the cost with which we are measuring it across. Maybe my PP itself could have been different, and the instrument is also. So whenever we talk about the new engineering products, like there is always a variation which is present, and that is being given. Where is this coming from? If you take this BP measurement product, it is today's products. They are not products; they are systems, which has got many number of systems. Each one of the systems is being made with number of components. Each one of the component has got its own variation. When it is combined, subsystem it is presenting a variation, and the system is presenting a variation. Overall, the output becomes quite a good amount of variation. So if we measure actual quantity of 120 or 80, it could be 130, 80. So what is the percentage of variation, what it can consider? That's what generally the instrument manufacturers, medical device manufacturers, or the outputs of the cars, any of the products normally be indicated in terms of what is the pressure, what is the variation. In this case, for a particular product, the manufacturer says that, this is what is the variation, what it is coming up. And, whatever the measurement which the instrument is showing, it could be 140/88 if we look at the display what is available. Actually, it could be 143 or it could be 137. Similarly, on the systolic pressures too. So this is the kind of variation. So what is that? No, even the system is becoming much more complex. Be it drones, be it robotic kind of environment. There are n number of things which is coming up. Say, for example, in this picture which has been presented, what is going to go through is the huge weight which is hanging from the roof. It is all these products are personally, I have worked with them. What we need to see is the monitor on which the picture is coming, and doctor is going to use the procedure in the procedural room, the huge weight which is going to hang on the roof, and this is going to be rotated depending on the need, and there are going to be X-rays at multiple directions. This is called something which is called cath lab, in two directional plane, in which the scan is being taken, the display is being shown. So to get a very beautiful angiographic images. But at the same time, if any of these variations are present, that will reflect in image quality or image not appearing at all. So that is what will appear. So we need to control the variation. So that is one of the reasons why engineers should know whatever the product, be it you are a component engineer or you are a system level engineer or you are a subsystem level engineer, you need to understand what are all the variations which is coming up, how it will impact. To understand the variation, if at all, if I'm understanding the variation, then only I will be able to control. Which variation is controllable, which variation is not controllable, we are going to see. We cannot eliminate all the variations. What are all the methodology? So towards this variation, what are we talking about? How to control them is what is that? What is needed is the data. The data has to be looked at. How we are going to say the data, what the data is saying is all that what we will see as part of the statistics. How my standard deviation is going to be helpful. We will see in the rest of the sessions which is coming up. So what I have said across is in this again is a system. It has got multiple subsystems in which, like it could be due to the mechanical, variations due to the mechanical subsystem hardwares or electrical electronics or networks or image acquisition system and reconstruction system. We acquire the image and we reconstruct and, due to the usage itself. So now we are, one more example is, like, this is the baby warmer, the infants which is premature babies. When they are being placed, they have to be subjected to a particular temperature in the warmer for them to survive and to make them up. So when we do this, what is happening? When we do this, what is happening is this temperature is being controlled, is being generated by the lights, by the other subsystem equipments, and the control has been placed by the sensors which has been placed on the infant's bed. So in this incident, somewhere the variation, either the pickup of the instrumentation system is not all right, or the heat that has been supplied is not all right, or somewhere the variation has caused in excessive heat being supplied under a new baby born, which is, which is resulting in death. So that is the impact of variation. So the data, if we constantly look at the data, we will be able to understand how much is the variation. If it is going to be 40 degrees C, is what is that to be supplied? Is it always 37 to 43? Or the variation if present is more, yeah, say for example, plus or minus 10 degrees, then it could be from anywhere between 30 degrees to 50 degrees. So that are all hazardous. So variation helps us out in terms of understanding and controlling them as its criticality. So we have a large amount of uh, responsibility as an engineer to understand the variation and to control them. So how do we do this? We do this by combining the engineering knowledge from the top-notch institutions and the best institutions from where we are all studied, and also understanding the statistics. This is where we should not be averse to understand the statistics and use it practically. I'm grateful to many people, particularly Lucas Tivius and in GE, where I had an extensive trainings went through. I had best of best opportunities to go through the statistical part of the training from the applications from stalwarts like Dr. Abhinandan Sarkar from Stanford universities and stuff like that. So, these are all something which I have learned and practiced in the last 20 years. I'm just giving it to you onto a platter so that you will be able to apply and practically use it. If 10 of you or 15 of you or 100 of you is getting benefited out of it, I'll be very happy that I have delivered what I have learned to the benefit of the country, to the benefit of the community, to the benefit of the society. Variations and varieties. Now, we need to understand there are two terms which normally we talk about, variations and variability. Variation, or we can always talk about variety and variability. The sizes. See here, the basket, for the sake of it, I have taken it across. The sizes are variants. This could be one family. This could be another family. So varieties and variations, like what customer expect is varieties. What customer don't expect is variations. What is the example? If you take the food, I have different kinds of things for my meal, which is being supplied, and I'll be too happy to have various, sweet, blah, 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 and all other things to have a very, varieties I need. If you take an automotive car, I have a budget, 4 lakhs, 5 lakhs, and, and so on and so forth. Each one of them has its got own features. So I have variety based on my budget. If you take the phones, mobile phones, you have varieties based on my capabilities, made based on my interest, based on my usage, based on utility I can choose. But within the product, I don't want to have a variation. Like say, for example, in this picture, I have put a variation onto this. If I'm taking the rice, which is a steamed rice, half is cooked and half is not cooked. There is, if the whole bunch of it is having a variation of distributed or a wide variation of cooked and uncooked, semi-cooked kind of rice, like that is what I don't, or as a customer, we don't like. I've taken some of the pictures. This is from my presentation last long time back made. Uh, the variants, I have taken only the few variants of the manufacturers of Maruti at those time. They present different varieties of the products as a manufacturer. That is what each one of them is needed for the customer segment. So customer segment based on that, like if I'm choosing for a lower end of the car, I have few more uh, dollars, few more $1,000, few more hundreds of dollars I can pay. I can get so little bit more features. That is variety. Variation when I am talking about, if I'm expecting about 40 liters per mile, 40 liters of fuel per fuelage, 40 liters per liter of the fuel. Um, you know, I expect consistently that is what is to be given every time. One time it is going to give me somewhere around 25, sometime it is going to give me 55. I'm seeing a wide variation. That is not within the same product. I'm not expecting that as a customer. This is the importance. So where is the variability and where is the variations which is coming up? I have talked about, like the variability comes, there are laws which we can uh, talk about it in the following slides. One is natural and another one is engineered. There are two variations which is coming up. One is controllable variation and another one is uncontrollable variation. Uncontrollable variations are those one which are also called as common cause variation. Controllable variations are those one which are all called special cause variations. Uncontrollable variations on which we cannot do anything. So you cannot make zero it down that there will not be any variation on any product. So that it should be controllable, because if you concentrate on uncontrollable variations to control, the cost of expenditure will be very high. I have an example. We will see what to do, and as we do, or some of the industries practices what they do, but special cost variation, controllable variation, I did identify from the data as well as my engineering knowledge, then control. Those are all the contributors towards special cost variations. This is first law of natural variability. Whenever there is an effect, which something is happening, there is always a cause. I mean, this is very, very fundamental principles for engineering and also for product defects to be fixed. The product behaves in a certain way, and that is not what you have expected. There is definitely a root cause. And engineer, whether if the process is not behaving in a certain way, and there is definitely a root cause. It could be from the it could be from any reasons. It could be from people. So that is where when we collect the data, is it from the missions, group of missions, or group of people, or group of ships? That is what is the data analysis will be able to give me if the process is behaving differently, at what time, but by what people, by what mission. This is where the data will be helpful to me. That is the reason why we should understand the practical knowledge of the statistics. Then we can fix it. This is what is controllable variation. Uncontrollable variation is something, like, whatever you do, you will not be able to always have one number. So that is one of the reasons why we always permit some tolerances whenever we make the design. So we cannot leave the karma theory, takes about whatever will happen. That is not, cannot be accepted for engineered products, actual products. This I have talked about, like this particular slide talks about common cause variation. Common cause variations are one which are uncontrollable, that's applicable to engineering as well as to applicable to nature's products. We cannot do anything. I've just picked up fruits on the same tree, the different kind of fruits which has come up in shape, size, color, and the fruits which is there inside over a period of time. So this is uncontrollable. Similarly, in engineering also, we have some of the components which we should not be able to work. And if you are trying to work on that, the effect will be very costlier. So the data will give me an idea which is a special cause, which is a controllable cause. And third law of natural variability is assignable cause. That is what I mean by special cause of variation. Say, for example, if a process is having a wide variation, is it coming from people, or it is coming from missions, or it is coming from shifts? If we identify from the data analysis, like this is largely coming from shifts, then probably we can work out onto what to do onto the shifts. If it is coming from people, then we can do a further data analysis to find out whether from experienced, inexperienced, or untrained people, who are all the contributors. So that is the further drill down will be able to fix, and probably we can take actions on training the people and stuff like that. And fourth law of variability is called measurement system, measurement variability, because inherently I have shown an BP measurement. That's a measurement system of the blood pressure. Invariably, it is also giving measurement system. Actually, 120/80 is not 120/80. It could be 123 as we have seen, or it could be 117 plus or minus 3 millimeters is what they have placed as a specification. So the measurement system is also bringing some variation. That is, there are methods and means by which it can be controlled, which are called gauge or under studies. That is not the focus. So there is an approach. If this is what do we want? We want the measurement system to give very minimized variation. The measurement system itself should not be occupying very, very large variations into the actual product measurements. Say, actually, my BP is 120/80. If it is measuring 117, 123 is fine. If the measurement system itself is going to have a variation of plus or minus 10, then what will happen is 120/80 is not 120/80. Maybe it is showing 110. Actually, mine is 120, or it is showing 130, but actually the measurement is showing 120. So when the instrumentation system is itself is having a wider variation, we have a problem. So to how can we address that? There is a specialized methodology using the statistical data, using the method which is called gauge error studies, which we will be seeing in some of the sessions once we finish it off. If by God willing, I will be able to present that in a separate session. So to address this variation, what do we need to do is target what is that, what do you want to measure? My BP is 120/80. I want to always measure 120/80 instead of having a very wide variation. So the focus is always be on the target. And there is always a shift. That I'm not going to talk about shifting of the process over a period of time, but focus by understanding the data, understanding the targets of variation, then we can always focus on what to control. So there are two things which you need to understand at this point of time. I have detailedly talked about variety and variability. Variety is needed. Variability is not the one which is appreciable. Variation within is what is the variation. And to understand the variation, we need to know about the data, collect the data, so we can drill down to understand what type of variation what it is presented. And there are two important variation which is coming up. One is the controllable variation, and another one is uncontrollable variation. They are also called as common cause variation and special cause variation. Uncontrollable variations, we can't do anything. Controllable variations are those one on which we can work on it by looking at the data. And apart from it, I have also talked about the variation which is coming from the measurement system, and the variability presented by the measurement system should be the minimal. Special cost variation is also called a sustainable cost variation. So this is exactly what the three components of variation. We can largely reduce this. If we reduce this, this will be. I'm sorry. This is what is largely reducible, where we can work from the engineering. This we have to keep minimum so that this one, to that extent possible, what it is we can address. We can address by addressing the common chaos variation yellow, by addressing the special cause variations, measurement system variation, we can bring down the common cause variation alone into the product. And this can also be addressed by addressing a most important area, robust engineering, that this wider common cause variation can also be talked about, bringing down to the minimum by addressing robust engineering. What is robust engineering is a separate topic onto that, and I will be dealing it in some of the separate sessions as I intend to share my all my knowledge. That's one of my specialities, robust processes and robust designs. So we are going to address all these variations. What we need to do is we need to have the knowledge from the data, marry it with the your domain knowledge, engineering data, statistical data. It is not that ours that that we will be able to the special cause and common cause variations. There is an interesting case which I have presented here. A printer, a printer which is automated printer, which is printing about, which can print 500 A4 sheets per day, for example. Ink smudging issues, which is coming up on a printed output or subject, one per day during a period. Look at this. January 13 to September 13 is what is that the smudging during that period, one per day, which happens. But during October and December, this is where the data, when it is collected, is helpful. This, if you look at the data and to the temperature of the environment around that time, you will find that it is during summer, the temperature is more. This is during winter, the temperature is very less. So this is exactly the common cause variation. You will not be able to address anything here because you cannot bring down room temperature. If at all, if you want to control it, then you may have to shift the machine to a AC room when the cost of printing will be going high. Whether it is needed or not needed is a different question. But special cause variations are coming from roller speed, toner brush, blah, 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 blah. So this we can address. That is what exactly what we have been talking about special. So the data helps out to control whether it is common or it is special cause, and which I can address, what I can address is exactly what is needed. And of course, I have other pictures, volume of filling during the bottles. There will always be variation. I have one of these success stories in the food and goods FNG manufacturing in South India, where with the filling we felt it uniform. The oil, it is a biological. I'm sorry, it is an edible oil that's been used for biological for human consumption. So they always want to ensure that they give at least exact quantity, even if it is 10 ml or excess goes up, it's okay for them. But the variation between exact quantity to the 10 ml was very high, and it is always very, very high. Working on that, 5 ml is what is that what we have brought down by controlling the variations. So that gave a huge savings. Okay, now we have talked about enough on common cause variation, special cause variation. By this time, you might have understood what are all those and how they are going to look at it from the data. We will be seeing how to do the data analysis, what it is bringing and all as we go forward in few sessions. But I have been saying that controllable variation, or common cause variation is difficult to control or it will be costlier. That's what it is. Say, for example, one of the why it is costly because we may have to invest a lot of money on that. The example is, currently the printer is not in a controlled AC room. But if you want to have the smudging issue addressed during the all the year calendar days of the year, then you may have to have it in a control room. When you are keeping it in a control room, the expenses which is coming up for per print, the output is costlier. But the common cost which was appearing on that example, the previous example, what we have seen is during winter, on which you don't have a control. If you want to control the controllable controllable part or common cause variation, uncontrollable variation, that is common cause variation is you need to spend huge money. This is the case of Intel manufacturing. Wherever the Intel manufactures the chips, they exactly produce, whether it is produced from Arizona, Mexico, or Ireland, they try to produce the same equipment, same material, same process, then steps by the workers. Copy exactly is what is the what process adopted in US, what process, machines, water, even including the water quality, they try to reproduce in order that so that the chips which is manufactured are uniform across the world. So this is the pain what they take across. So when we do this, you can understand what I'm saying is controlling the common cause variation. You can reduce the variation, but at the same time, it is going to be costly. So most of the engineering products, when we work on special cost variations. When special cost variations are coming up, we need to understand the data analysis. To do the data analysis, we need to have an understanding of the statistics. Then only we will be able to understand how the practical application now it is getting converted. You might have understood from this whole of the discussions, introduction and importance. The approach is elimination of all common cause variation in instrument coming from an instrument or from special cause is costly, but minimize the effect by controlling the causes. That's what we will try to do. So understanding of statistics is important. By this time, you might have understood that why I am an engineer. Why should I? Most of the time I have seen during my PhD also, one of my, I had done my PhD in employability, quality of education in India and employability was what is the why the employability is suffering is one of the gap from the industry expectations to the knowledge, practical knowledge, what is coming up is in statistics, practical statistics. In fact, we have introduced in a couple of good number of institutions, autonomous institutions, universities, the statistics as a course and a couple of other things which came up. So generally, when we look at the statistics as a course, when we do in the institution, we do study about all the equations and stuff like that. How they are getting used is not what we are finding it. And I have been running this course before running this. The design of experiments or measurement system analysis or any other, hypothesis testing, any of these things have been very popular programs which has been part of the Six Sigma certifications, which is offered by RISE in the corporates and the industry in-house. This program has been run, Introduction to Statistics, one of the most popular course. It is 1.5 days of the session plus a half a day of the session of their actual own data, 2 days of the program. I'm trying to split that in each one of the 30 minutes to 40 minutes and give the 1.5 days or 2 days of program. Unfortunately, online, I will not be able to give. And, you will be able to get the details, and I will be too happy to share my knowledge. You can send me mails or you can put a note. We will be able to connect. And to that extent possible, I will try to answer your questions. I think with this, robust product and robust process requires an understanding of controlling the variation. This is exactly later point of time when you are talking about robust engineering, Tauchi method, you should understand the data and you should understand the variation. This is what we are trying to understand and control the variations and know the variation. To reduce the variation, we need to have a good knowledge on statistics and data analysis. So we need to understand the data type distribution, statistical terms. We will see rest of them in the next sessions. So with that, I close this day's session and post me your needs. Thank you. Thank you so much. Hope it is useful. You also send it across to other people and share with other people. Share when you are my mentees, you can share to your juniors, and I will be happy, particularly for the postgraduates and engineering graduates, for their projects to give a practical feel of this. Thereby they can be more employable. And for industry people, I will be able to help you out in your data, look at your data, and support you. And there is no other expectations from me beyond this for sharing my knowledge. And thank you so much. Thanks to everyone. Thank